So these will be the last 4 lessons we cover this year. We will cover sections 1 to 4 of Chapter 7. We will have a quiz on sections 1 to 4 of Chapter 7. And that will be the last thing I ask you to do for me this year. So most of what we're going to be covering, sections 1, 3, and 4 actually, all deal with exponents. Section 2 deals with scientific notation. Exponents we have dealt with, I believe you started working with these in 5th grade, if I'm not mistaken. An exponent is a superscript, meaning it appears higher up on the line, that tells us how many times to multiply a number with itself. So a positive exponent, which you've been dealing with now for 4 years, is something like x squared. The exponent of 2 means we have 2 x's to multiply to them together, so x times x. One of the other exponents we've come across is 0, and there's just a simple rule for that. Anything to the 0 power is 1. And then we have negative exponents, and we did, if my memory is right, come across these in 7th grade, but it's probably been a year and a half since we've talked about them. So a negative exponent simply means move me. And by move me, I mean think about negative exponents appearing in terms of a fraction. If a negative exponent appears in the numerator of a fraction, it's saying move me to the denominator. And when you do that, you make the exponent positive. If a negative exponent appears in the denominator of a fraction, it's saying move me to the numerator and make me positive. So x to the negative 2, and it might be easier to think about that as the fraction x to the negative 2 over 1. X to the negative 2 says move me to the bottom and make me positive. So it becomes x squared in the denominator. The 1 is not flipping places here. Okay, the reason that there is no 1 written with the x squared in the denominator is because it's kind of pointless. It's 1 times x squared. That's unnecessary. The reason there's now a 1 in the numerator is because it doesn't become 0. Okay, when we are working with exponents here in this chapter, we will sometimes clear out an entire numerator or an entire denominator. When that happens, it's not 0 that's left behind. That would cause us serious problems if it happened in a denominator because we can't divide by 0. What's left behind is 1. So let's talk about doing some of these. Please know that anytime we have a number raised to an exponent, I expect you to actually work it out. You have access to every piece of technology you could possibly want right now, given the distance learning, so there's no reason that you can't figure out what 2 times 2 times 2, or negative 3 times negative 3 times negative 3 times negative 3, so on and so forth. You can figure the number parts out without much difficulty. So let's start with 2 to the negative 3. That is a problem because we're not allowed to have a negative exponent. So what we need to do is say, okay, secretly, you've been a fraction all along. And the negative exponent screams, move me to the denominator. And when you do that, it becomes positive. So it's going to be 2 to the third in the denominator. In doing so, in moving this, we've cleared out the numerator, which means there's a 1 left behind. All we need to do now is figure out what 2 times 2 times 2 is. 2 to the third power. 2 times 2 is 4. 4 times 2 is 8. So 2 to the negative third power is 1/8. Next example, we have negative 3 in parentheses raised to the negative fourth power. Okay, I know the parentheses cause issues for some folks. Again, we're going to want to consider this as being the fraction negative 3 in parentheses to the negative fourth all over 1. The exponent of negative 4, not the fact that the 3 is negative, that doesn't matter. The exponent of negative 4 is what tells us that, hey, move me to the denominator. And that's going to include the parentheses. In doing so, we clear out the numerator, so it becomes 1. So now we have to work this out. So it's going to be 1 over something. Because the negative 3 is in parentheses, and the exponent of 4 is outside of the parentheses, that tells us that we're going to take negative 3 times itself 4 times. That means we're looking at negative 3 times negative 3 times negative 3 times negative 3. You need to be very, very, very careful with this. If you just type the negative sign 3, the caret key on your calculator, and 4, it's probably going to spit out the wrong answer. You have to use the parentheses. If your calculator doesn't have parentheses for some reason, then you're going to have to work this out by hand. Otherwise, you're always going to run the risk of having a sign error. So, since I have this written out, I'm going to do it by hand. Negative 3 times negative 3 is positive 9. The third negative 3 times the fourth negative 3 is also positive 9. 9 times 9 is 81. The answer is 1 over 81. If you don't use the parentheses, you're going to wind up having the calculator tell you negative 81, which means you're off by the sign. 1 over 81 and negative 1 over 81 are not the same thing. Remember, parentheses mean I am the base. The whole negative 3 is the base. And that's why the next example is negative 3 to the negative 4th. No parentheses here. The lack of parentheses means that first negative sign is simply there. It exists. It's telling you that the whole thing is going to be negative no matter what. So it's not really part of the 3 to the negative 4th. It just is part of the numerator. So again, I'm going to make this over 1 so we can see what we're doing. The negative 4 screams, take me, move me to the denominator. It's on just the 3. So we have 3 to the 4th in the denominator, and essentially the negative sign left in the numerator. Of course, we can't just have a negative sign, it's got to be a number. So when every number clears out, 1 is what's left. So now we have negative 1 over 3 to the 4th power. 3 to the 4th power, we just kind of figured out actually, is 81. Okay, so a negative exponent says, move me to the other part of the fraction. Parentheses are important because they'll tell us whether the number we're multiplying is negative, or a lack of parentheses will tell us the answer is negative. Evaluate. So these are plug in and solve. So evaluate x to the negative first power for x being 2. Okay, the first thing you should do is write down 2 to the negative first. Replace x with 2. Negative exponent should scream at you, move me to the denominator, where it will become positive. So now we have 1 over 2 to the first. And 2 to the first is just 2. Anything to the first power is itself. Next up, we have a to the 0, b to the negative 3, for a being 8 and b being negative 2. Okay, so the first thing we're going to do is replace a with 8, and that's the 0 power. B is negative 2. If we're placing a negative number into an expression with parentheses, we want to put the negative number in parentheses, or strike that. If we're putting a negative number into an expression with exponents as a base, we want to put that negative number in parentheses. So let's look at what we got here. We have 8 to the 0 and negative 2 in parentheses to the negative third power. Anything to the 0 power is 1, and 1 times anything is the thing it's multiplied to. So this 8 to the 0 is trivial. We can ignore it. which means all we're looking at here is negative 2 in parentheses to the negative third power. So that'll become 1 over negative 2 in parentheses to the third power. And negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. So negative 1/8 is the answer here. Lastly, you'll be asked to simplify. Simplifying means get rid of negative exponents, get rid of anything to the 0 power, because anything to the 0 power is 1, and in these examples at least, 1 will be trivial. So, in order to do this, we have to realize that everything we look at is its own piece. So in this first example, 3y to the negative second, 3 is its own piece, and y to the negative second is its own piece. The reason I'm pointing this out is that the 3 does not have an exponent, which means it's not going to be forced to go anywhere or do anything. It just exists. It's there. It's the y that has the negative exponent that causes us the headache. So when we go to move around the things with negative exponents, only the y to the negative 2 moves. The 3 stays exactly where it was. So the 3 gets to stay where it is. The y to the negative 2 has to move to the denominator, and it becomes 3 over y squared. And you'll have to excuse my whining pooch. She is very distraught. Nobody is currently paying much attention to her because my wife and I are both working. She'll get over it. The next example, again, let's take a look at the fact that there are multiple pieces here. There's a negative 4, which is fine because he's just a number. He doesn't have an exponent. And there's a k to the negative 4, which is a problem because he's got a negative exponent. Negative exponents say, hey, move me to the other part of the problem. This is the first one we've seen in a denominator, but that just means move it up to the numerator. So negative 4 is in the numerator. K to the negative 4 is coming up as k to the 4th, which means we've cleared out the denominator, which means the denominator is 1. Do you need to write that? No. A denominator of 1 is pointless. Negative 4k to the 4th is the correct answer. If you do write it over 1, I'm not going to mark it wrong. Last example here. This guy has 3 parts. We have x to the negative 3. We have a to the 0. And we have y to the 5th. So when you look at these, x to the negative 3 is going to have to move because it's got a negative exponent. A to the 0, we're actually going to cancel because anything to the 0 power is 1, and 1, when we're multiplying and dividing, is trivial. It's pointless, doesn't do anything. And y to the 5th is fine, gets to stay exactly where it is because it's got a positive exponent. So y to the 5th is already in the denominator, and it's fine. X to the negative 3 has to move to the denominator to become positive. So x cubed now in the denominator. And in doing all of this, we've cleared out the numerator, so we have to put a 1 up there. Here, that 1 in the numerator is essential because our answer is supposed to be a fraction, 1 over x to the 3rd y to the 5th. When 1 is the denominator, it's pointless because you're dividing by 1, whereas in this case, you're taking 1 and dividing it by stuff. And those usually aren't the same thing.